Hi, we are back. So this is our second lecture, and this is regarding circuit analysis using Laplace transform. Now, in this lecture, we have discussed about the basic formula which we will be using to solve the circuit analysis. Okay, so let me start. This is the first. So what is actually Laplace transform doing? The Laplace transform the time domain equation into the frequency domain equation. So as far as concerned about the formula, Laplace transform of ft is equal to fs, and this is equal to minus infinity to infinity integration e की power minus st ft dt. Now it is called the double sideband Laplace transform, and for the single sideband Laplace transform it is equal to 0 to infinity e की power minus st ft dt. It is called the single sideband Laplace transform. So technically what happened, the double sideband Laplace transform is equal to minus infinity to 0 e की power minus st ft dt plus 0 to infinity e की power minus st ft dt. And in this condition we have assumed that minus infinity to 0 e की power minus st ft dt is equal to 0. So means we are talking about the initial conditions are equal to 0 for this single sideband Laplace transform. Okay, and that is clear that ft the Laplace transform of ft is fs, and inverse Laplace transform of fs is equal to ft. Done? Now, see, we are going to discuss about the basic formulas. I hope in basic system analysis in AKTU syllabus in third semester, you have gone through the Laplace transform, and here is just a small recap of all these formula. So first is Laplace transform of 1 or any constant is equal to 1 by s, or if there was 5 then 5 by s, or if there is any constant then constant k, so there is k by s, right? Now Laplace transform of ut, where ut is a unit step input, Laplace transform of unit step input is equal to 1 by s. We are saying unit means its magnitude is 1, and unit step input is defined as that is equal to 1 when t is greater than equal to 0, or it is equal to 0 when t is less than 0. Okay. Now Laplace transform of unit ramp input. Unit ramp is defined by unit ramp input rt is defined by rt is equal to t when t is greater than equal to 0, or equal to 0 when t is less than 0. And the Laplace transform of rt is defined by 1 by s square. Okay. Now third, Laplace transform of t की power n, and t की power n is equal to factorial n upon s की power n plus 1. ठीक है. Now Laplace transform exponential function, Laplace transform of e की power at is 1 upon s minus a, and Laplace transform of e की power minus at is 1 upon s plus a. Laplace transform sin omega t is omega upon s square plus omega square, and Laplace transform of cos omega t is s upon s square plus omega square. So these are some shifting property. If you are saying Laplace transform e की power at sin omega t is, so what we will do? They will be shifting in s only. So it will be like omega upon s minus a square plus omega square. I repeat, sin omega t's Laplace is omega upon s square plus omega square. And while we are talking about e की power at sin omega t, so they will be shifting in t by small a, and there will be omega upon s minus a square plus omega square. Similarly, when you are talking about the cos omega t, so it is e की power at cos omega t, its Laplace is now will be shifting in s. Here there was a shifting in s. So there is a shifting in s, and the shifting is s minus a upon s minus a square plus omega square. Okay. Now in the very same fashion, if we were having e की power minus at sin omega t, then its Laplace transform would be omega upon s plus a square plus omega square, and if it was e की power minus at cos omega t, its Laplace transform would be s plus a upon s plus a square plus omega square. Hope that is clear. Now there is an impulse function delta t, and delta t is defined by delta t is equal to 1 when t is equal to 0. It is unit impulse function. So delta t is equal to 1 when t is equal to 0, and it is equal to 0 anywhere else. means when t is not equal to 0. So Laplace transform delta t is equal to 1. Now there is some properties. If we are given Laplace transform of ft is equal to fs, then Laplace transform of e की power at ft is fs minus a, and Laplace transform of e की power minus at ft is fs plus a. जैसा हमने पहले डिस्कस किया था, e की power at sin ओमेगा t and e की power at cos ओमेगा t में. Now लाइए, if ft का Laplace transform fs है, then dft by dt is derivative. So we are saying Laplace transform of dft by dt is sfs minus f0 positive. I repeat, Laplace transform of dft by dt is equal to sfs minus f0 positive, where fs is Laplace transform of ft and f0 is equal to limit t tends to 0 ft, or the value of ft when t tends to 0. Okay. Now Laplace transform of integration of ft dt. Laplace transform of integration of ft dt is fs by s. Now this is a time shifting. Laplace transform of f small t minus capital T. So Laplace transform of f small t minus capital T is equal to e की power minus st into Laplace transform of ft means fs. I repeat, Laplace transform of f small t minus capital T is equal to e की power minus st and into fs. Similarly, Laplace transform of f small t plus capital T, it is equal to e की power st into fs. Now last, we are talking about the initial value and final value theorems. These are very important when you are having a discussion about the transient analysis, because you need to understand the value of t equal to 0 value, and you have to understand the value of t equal to infinity value. So initial value theorem provides the value of ft at t equal to 0. So what it is? Limit t tends to 0 ft is equal to f0, and its value in Laplace transform is limit s tend to infinity s fs. Okay, I repeat, initial value theorem is limit t tend to 0 ft, and it is equal to f0, and its value is limit s tend to infinity s fs, where fs is Laplace transform of ft. Similarly, the final value theorem is equal to limit t tend to infinity ft, means we are talking about the value of ft at t tend to t is equal to infinity, steady state value. So this value is equal to limit s tend to 0 into s fs. Okay, so this is all about the formula which we will be using in transient analysis of any circuit using Laplace transform.